Hello students, welcome to our TEJAS series. So those are the two questions from algebra today. Let's solve the first one. तो पहला क्वेश्चन आपका definitely binomial coefficient की series का है. देखिए, you need to remember the result here. What's the result and why I selected this as a special question for today? See, the purpose is, first of all, we have a result and it says that MCP, summation of MCP into NCQ, where of course rather I will write it something like n minus r. Okay, so n minus p, something like that, where p goes from maybe 0 to m, whatever what are the condition. The important thing here is, if you have a series of product of two binomial coefficients with two conditions. First condition is that the sum of the subscript of each term, every term of the series should be a constant, which is the case here. If you add the subscript p and n minus p, you get n, which is of course a constant, because variable of the series is, or summation is, p here. Okay, and second condition is, you should have all the terms of the series. Then the sum is given by directly m plus nc, the sum of the subscript. So the answer is sum of the superscript, which is m plus n, and whatever constant sum you have for in every term of the series of the subscript. So that will appear in the subscript. That's the answer. Okay, so all of you must be knowing it. If not, then note down this result. This is extremely important result. But are we like going to use that result directly here? My answer is no. Why? See, here again, first of all, I'll be rewriting this series, because first we need to see, do we have all the terms of the series? Answer is yes. How? You put r equal to 0. You can't have a binomial coefficient preceding 20c naught. You put r equal to 0, you get 20c naught. So definitely r can't start before 0. Now you put r is equal to 9, you get 20c20. So of course you can't exceed 20c20. So you have all the terms of the series, means the limits are there. Of course, limits are there. The catch is here only. So that's why I smiled. Anyways, now the second case is, do we have the sum of the subscript, not the superscript, the sum of the subscripts as a constant? Answer is no. But we can definitely do it. How? The way you would have seen here, I replace q by n minus p. Okay, so the same thing I'm going to do here. I will rewrite it as 20c. So we know ncr is equal to nc n minus r, bacho, isn't that? We all know this. Okay, so I'll be writing 20c n minus r, so it will be simply 18 minus 2r here. Now add these two and you have a constant number 18. So whatever value of r you put here from 0 to 9, the sum of the subscript in every term is going to be 18. But the point is, do we have all possible terms of the series? Answer is no. Why? See, now open the summation. What will you get? You will get 20c naught into 20c18, that's the first term, 20c2, 20c16, the second term, 20c4, 20c14, the third term. Now the point is, can we get sum as 18 only with the help of these combinations? Answer is no. The numbers, the terms which are missing, must be having the odd subscripts. Like, what are we missing? 20c1, 20c17, 20c3, 20c15, dot dot dot. So one condition fulfilled, sum of subscript in every term is a constant. The other condition is not fulfilled. So what to do? So for that, I will suggest you all to go back to the proof of that result. Which result? This result. Okay, so how will we get it? So I will say, okay, let's consider this binomial expansion quickly. See, that's why that's the purpose of this series, bacho, to discuss everything in detail, so that you should know every in out of the questions. Okay, so it's 20c0 plus 20c1x plus 20c2x square plus 20c3x cube, and I'm not going to write more than that, dot dot dot. Similarly, I'll be considering one more binomial expansion here, the same rather. So it will be 20c0 plus 20c1x plus 20c maybe 16x raised power 16 plus 20c17 x raised power 17 plus 20c18 x raised power 18 and dot dot dot. Okay, Now, why I stopped at 18, why I wrote specifically these terms, the purpose is when we will be multiplying these two binomial, we will get 1 plus x raised power 40 in LHS. In RHS, we will get several many terms, but I am interested only in those terms which gives us x raised power 18. So collect those terms. So 20C naught into 20C18, this one. So that's the first one, 20C naught, 20C18. Plus, if you pick up this term from the first expansion, you have to multiply it with this term to get x raised power 18 here. So next term will be 20C1, 20C17, likewise 20C2, 20C16 and so on till 20C18 into 20C naught here. Now that's it. So what is it? So this is the series which you can say, okay, this is like 20CP and then 20C18 minus P, where P goes from 0 to 18. Okay, and how will we get the answer? So, of course, that's an identity statement. LHS is equal to RHS. That's an identity statement. So, the coefficient of x is raised to the power 18 need to be same on both the sides. So, here I will just collect the term with coefficient with x raised power 18. So, its coefficient will be 40C18. So, that's the answer for this series, bachon. Okay, now what we need is the even terms of this series, not the odd terms. So what do we do in that case? I will be replacing x by minus x here. So here itself I am doing it. So this is plus, this is minus, so this remains as it is, minus, this is plus, minus, plus and dot dot dot. Okay. Now if I multiply the first and the second, the difference is now you don't have same base, so you are not going to get 1 plus x raised to power 40, rather you have same power, different base. So base will get multiplied 1 minus x square raised to the power 20, and now again the same thing, you will collect the terms for x raised to power 18. So what will you get? 20C naught into 20C18 minus 20C1, 20C17 plus 20C2, 20C16 minus dot dot dot. Now again, what will be the answer for this series? So again you have to get the coefficient of x raised to power 18 here, which you will get when you will raise this to power 9. Raising this to power 9 is an odd number, will give us negative value. So 20 minus times 20C9. So this is nothing but this is like minus 1 raised to the power R20C. R20C18 minus R goes from 0 to 18. Now add these two series, bachon. If you add these two series, what will we get? So one in LHS we have 40C, what was that? I think 18 minus 20C9, and in RHS, see, the odd terms will get cancelled here. The odd terms, so this is like 20C1, C17 minus 20C1, C17. Similarly, 20C3, C20C15, all such odd terms will get cancelled. You will be left with even terms, and that too twice. So it's 20C naught, 20C18 plus 20C2, 20C16 and so on and so on. That's our series. So the value of our series is, which was 20C2R, 20C18 minus 2R, R goes from 0 to 9, will be 40C18 minus 20C9 whole divided by 2. That should be the answer, but then again there's a catch. Answer is not given in direct form here. So it's not given in direct form here. We need 39C, 21, 19C10. Okay, so I'll be rewriting it here. So I'll be rewriting it. So our answer is, I'm writing it as S for the series. So it's half times. So since we don't need 40, we need 30. So let's open it. So 40 factorial, 40 into 39 factorial. Okay, upon 18 factorial, and then see what we need, 39C 21. Here you will get 40 factorial upon 18 factorial into 22 factorial, which I will write it as 22 into 21 factorial. Minus again, you don't need 20 factorial, so 20 into you need 19 factorial, 19 CR upon, so what do we need? 10 factorial. So you are going to have, see, 9 factorial is okay, but 11 factorial, so 11 into 10 factorial. Okay. So now what? So let's try to simplify it a bit. So what are we going to get? Yeah. So if I reduce it, so 20 and 11, we have 11 in the denominator, 20 in the numerator, so 20 by 2 into 11. Now let's write it, 39 factorial by 18 factorial into 21 factorial, 1 minus 19 factorial by 9 factorial into 10 factorial is the second one, bachcho. Now I think we got the answer here. So it's 10 by 11, p by p plus 1. What is it? 39 c 18, isn't that, or 21, whatever you like, I don't know what's given there, and it's 19 c 10, I think that is definitely given there. So 39 c 21 is the same thing, and 19 c 10 is there. So this is p upon p plus 1, so therefore p is 10 here. Okay, so that was the purpose of this question. The first thing, this result. Second thing, of course, how do we get that result? And one very important aspect, bachcho, whenever you have to collect just even terms or odd terms of the series, you need to consider twice the same expansion, once with 1 plus and once with 1 minus. Okay, so that's it for the first question here.